I invite Tim and David to take place behind the tables. Let me start with inviting you to ask some technical, purely did I understand well questions. And after that, we go into the consequences and the real big system thinking questions. Who was not sure to have understood every slide and every sentence that was said?
No, sorry, I have no question in this, but I was not sure to have understood every slide and every question.
What's your question? What is your question?
I don't have technical question here because I didn't understand many things.
Yes, that's no question. I'm looking for maybe.
You're just being honest.
Yes, just being honest. One question.
Yes, very short question. Which concern of the effects, big variability of the effects of minimum tillage and limitation of tillage, which concern of some not mistakes of the experiments, but defect of the experiment, which concern of sowing term. You know, in every experiment, you have the same term, but usually, mainly in clay soil, we have such situation. The sowing term, when I make a limitation of the soil cultivation, the sowing term is yearly, even 2 months it can be. So the effect this time is very high, you know. But almost every, I think on every, it is not mistake. If I make such in the experiment, the cultivation should be the same time, but I think it is big defect.
Did you not forget the sowing time of the croppings, the crops that you investigated?
Yeah, you can find many factors explaining the heterogeneity of the effect of no-tillage system. Yes, we extracted as well the sowing time of the crops from the experiments. We include it in the model. It had an effect, but it compared to the effect of other factors, it was not that important actually, but you have to keep in mind that this analysis is analysis at the global scale. So we are comparing many different situations. So the ranking of the inputs according to their influence is valid at the global scale. It doesn't mean that this ranking will be similar in every part of the world and for all soil types. So yes, I agree that there are a lot of factors explaining the variability, and that's why we have this huge heterogeneity, and that's why it's quite difficult to predict quantitatively exactly what is the yield gain or loss, and that's also why we remain a binary here. We don't predict exactly what is the yield loss or gain, but only if there is a gain or a loss.
Okay. I invite you to formulate short questions.
Okay, I'll try. I wanted to comment on your experiments or your reflections on the erosion issue regarding the tillage and no tillage. Because from my point of view, it is really essential to include not only the tillage or no tillage, but also what you do in addition to the tillage or no tillage, or when, and that, because that, in my opinion, determines completely whether you will have more erosion or less.
So what's the question?
If you could tell me how this was included in your meta-analysis.
Yes, so my meta-analysis was not about soil erosion, it was about crop yield. The example I shown on soil erosion was published by other people. What I've seen in this meta-analysis is that what they do is subgroups. So they provide a global mean value, and after they are aware of the existence of other factors impacting the effect of soil tillage and soil erosion. So they try to do subgroups by climate zone or by the soil types or by additional practices. For example, quite often, as I explained, they consider the addition of soil residues to see whether it has an impact or not with soil tillage. Yes.
Okay. Next question.
I'm wondering how the system that you were describing for no tillage deals with rare events, because I think that was one of the sort of main drivers of conservation tillage, that it actually in years when there's a really dreadful rainfall or something, that it's actually quite resilient. And how do those models actually deal with that rare event?
So I think it's a very good remark, and I think this is a big limitation of the work that we have published so far. What they publish mainly is average impact. But clearly, the occurrence of extreme events is a very important issue. I'm quite optimistic in our capacity to adapt cropping system to change on the long term. So I'm not very much worried, for example, by the impact of climate change on the long term, but I'm much more concerned with our lack of ability to adapt quickly to extreme events. And I think we need to work more on this topic. Yes, I agree.
Okay, good suggestion.
I have a question to Tim Serginger as an economist. Did I understand you correctly that you would demand higher prices for land, but for land use change? Would this result in higher land prices or lower land prices?
Switch on?
Yeah,
Yes.
but I'm not suggesting we actually do that. What pretty much it's almost true by definition, that if what you wanted to do is have a completely efficient way of dealing with climate change, you apply a carbon price to everything. So everyone who emits a ton of carbon pays the price. Everyone who takes carbon out of the air is paid. And that means that the price of everything reflects the effect on climate change. So if you consume something that causes emissions, you have to pay more money. If you do something that reduces emissions, you're rewarded.
Okay.
But that's just theoretical. So we're not going to do that for lots of reasons. But what we want to make sure is that our own accounting, so what you do, everyone in this room does when they account for the greenhouse gases, it achieves the same result as if there were a carbon price. And so in that system, the very use of land has a cost. Not just land use change, just using a hectare of land has a cost, because it could be used to store carbon otherwise, or produce food that allows other. So that's what you're trying to imitate. And you can basically factor that in from a food production standpoint. And you produce more food, that's a benefit equal to the amount of carbon on average that saves on land in the world. You produce less food, it's a cost.
Okay. So the resume is that we should treat land users as if they were production processes. Positive, negative for climate effects.
So here's one way to think about it is you want to make a car. In order to make a car, you have to start by making a car factory.
Yeah.
A car factory causes emissions. You want to make a crop, you have to start by making crop land. That causes emissions.
It's a resource.
So it's a resource. So that use has to have a price from an emission standpoint. We're not really charging anybody.
No.
But when you do your calculations, you need to factor that in.
Yeah. Next question for both of you.
Actually, one for Tim and three short technical ones for David. So the one question, I have to choose one? Yeah. Okay, for Tim. You shortly mentioned that deeper rooting could be a double win. If I understood that correctly, could you elaborate on this?
Well, this was something I was talking with somebody last night, because normally you would think, well, if you're increasing production in roots, you're decreasing the harvest index, you're actually decreasing yields, right? We've spent decades trying to reduce the production of anything but grain. But someone was pointing out, I think Anton, that in the future with climate change and drier systems, and that having roots that are able to absorb water from farther down could actually be yield enhancing. So if that's the case, then that's something you want to do. It's a double win. So I think it's an interesting idea.
Next question.
Yeah, also to Tim, yeah, following up on the deep rooting also. Yes, you made very clear points. Thanks for this, really great. Do the points become even clearer when you also consider the use of the water?
So obviously there are two factors that determine the productivity of land. Above all, how much water and is it warm? And they often go together because actually a lot of boreal areas are dry actually. So they're cold and dry, they don't grow a lot. So the most productive land in the world is warm and gets a lot of rainfall. So that's a cost, yeah. And there could be trade-offs. So here's an example, which is terrible for biodiversity, but it's good for carbon. You take tropical savannas that produce a lot of plants, but don't sequester a lot of carbon because they have fire. You turn that into a wood plantation. That will absorb a lot more water, potentially have lots of adverse water consequences, but it will absorb more carbon. So there are occasionally times when there's trade-offs between biodiversity and carbon. But most of the time, for biodiversity, I work on biodiversity, the single most important thing is stop converting habitats. And if you look at Europe, for example, people have forgotten, people tend not to focus on the biodiversity that they don't see. So people in Europe are obsessed with farmland birds, which are birds that weren't as common, but took advantage of kind of all of the tourist farms. But basically about a third of every taxonomic class in Europe is seriously endangered and is surviving on tiny, tiny areas of habitat left. And if you want to protect biodiversity in Europe, you basically protect and try and expand and buffer those habitats. And so again, land expansion is the key issue.
Okay. Did I have, and it's a yes or no answer, did I understand both of you well that you are rather in favor of intensifying and sparing land? Yes or no? And then next question.
I agree with Tim when he says that we have to protect, when we have to protect natural habitats. I think a lot of evidence go to this direction. For intensification, actually I have a question to Tim, because I think that if you increase a lot the productivity, it may decrease the prices. If the prices decrease, it can increase the demand, and a higher demand can put a lot of pressure for cropland expansion. So, I feel that intensification, increase of productivity, does not necessarily lead to less land. It can actually lead to more croplands if it induces an increase of the demand.
So the issue is whether when you increase productivity, you reduce the price, people consume more, and therefore you'll have more land use change. Now, let me just start by saying that if you don't increase the productivity, you are guaranteed to have massive land use change, right? Even at existing consumption levels.
Okay.
So
next question.
Yeah, my name is Jan Verhagen from Wageningen University Research. I've got a question for both of you with links to adaptation, because you both do global studies. I think David already mentioned that he wants to go to look at extremes. I think Tim is also looking at activities, and they actually have to land somewhere, and normally that's the land manager. And it's already moving. I mean, we're not in a still standing sort of vehicle where we're on a train moving, and some areas on the globe move in different speeds than others. Did you take that into account, or you're planning to take that into account? In terms of yield increase, that's the most simplest one, also related to the previous question, because there's a lot of gain to be held in Africa and other areas. So do you do that, and how are you going to do it?
yeah, we look at this. Yeah, we look at this everywhere. And the short answer is We have to do everything we can, every possible way, everywhere, to have any chance. Oh yeah, absolutely. We look at yield gains in different places, et cetera. Both. So I have a new analysis. But you know, you can do these complicated modeling analyses, but at the end of the day, you can also do a lot with the back of the envelope. So let's take Africa. So people talk about the potential to gain yields in Africa. It's also the case in the last 10 years, there have been almost no yield gains in Africa, with the exception of 2 countries. I have a new paper where we're looking at what happens if you just continue present trends in Africa, where the population will double. And if you have any income growth, you'll also consume more meat. And the answer is you'll convert hundreds of millions of hectares of land, and of a disastrous level. And so Europe, for example, is the exporter of wheat to Africa. And Africa is a terrible place to produce wheat, right? For obvious reasons. It can produce a lot of other things, but you really don't want to be producing wheat in Africa. So yeah, on a global basis, you know what you want to do? You want to produce the things in Africa that you produce well and export them to Europe. And you want to produce the things that you produce well in Europe and export them to Africa. And most other studies will also find benefits from trade in this regard. But the short answer is everything. It is really hard to come up with a scenario that does not have massive land use change in the future.
Next question.
A question about the European subsidy policy for the farmers. What do you think? So we have measurement-oriented approach for increase the carbon content in the soil. And we here at this conference, we are talking about the carbon content, this approach, the target to increase this. If we heard your presentation, the measurement-oriented approach is the solution. What do you think about this? I think this is a great question, how to have the acceptance by the farmers. And we have seen here the measurements you can see, but the problem is, what do you think about, please? Thank you.
We want soil carbon, but paying people for the amount that they gain is a mistake, for the reason I said, that I will just steal the carbon away from David and get paid for it, right? I'll just take the manure. David's using manure on his farm. He can't be paid for that because he's already doing it. Or if you pay him for that, you're going to be paying a lot of money for something that's already happening. So no additionality. So I can get paid for that. So I'm going to take David's manure and I will be paid for building the soil carbon. And what you have to think about when you have an incentive system is you have to assume that people respond to the incentive system and they're smart about it, and they will do that. So what you will simply have with a payment system per farm is you will be taking carbon away from some farms and giving it to others, and they'll get paid for it. And you'll call that a gain when it's not. So instead, what you need to have is an activity-based system that rewards people for the activities that actually build carbon overall. They don't simply move it around. Unless you think we're somehow going to have a system that says, I'll pay you for carbon, but not if you apply manure. Which is crazy, right?
Clear opinion. Next question.
Yes, I also have a question to you, Tim. Thanks for the great presentation. I wonder about the time dimension of the carbon costs and how to account for this. Because if you, for example, a forest, you one time get money, but you can, if you don't a forest, get maybe a little more money, but for hundreds and hundreds of years, if you continue cropping. So how to combine such a one-time economic gain with a very long-term potential smaller gain?
So for all land use change, that's the question, right? And intuitively, everyone here understands that we need to focus on the next few decades. So the question is, can we avoid desperately dangerous climate change in the next few decades while we hope to develop the technology and the political will to solve it in the long term? Or will we already be dead, right? Which is quite possible. Plus all the damages in between. Plus, when you just think of the time value of money, right? If mitigation costs are going to go down, here's one way to think about it. The cost of your computer or your iPhone or your equivalent phone for the same quality goes down. But you want it today. So you have to be willing to pay more for it today than in the future. So everyone intuitively understands, yeah, look, we need to be focusing on what can we do in the next few decades. Now, the economic rigorous explanation of that is that that's actually true for two reasons. One is the first reason I said, which is we're probably going to have declining mitigation costs over time, but we need mitigation today. We have to pay for it more. The other rigorous explanation is simply the time value of money. So if somebody says, I'm going to give you 100 tons of mitigation today, and David says, no, I'm going to give you 100 tons of mitigation in 40 years. So you offer me 100 tons of mitigation today. David offers me 100 tons of mitigation in 40 years. Who am I going to pay more for? I'm going to pay for you. Why? Because if nothing else, I could take $100 and put it in the bank and make money. And then when I pay David, I still have extra money left. So there are lots and lots of rigorous reasons. And here's the simplest way to think about it. Think of it as a rental cost. So if you lose 100 tons of carbon from land, the rental cost at 4% is 4 tons per year. So if I'm going to use land, I pay 4% of the lost carbon per year. And that's forever. Every year, forever. You always pay that cost so that's the way to think about it.
Okay.
And let me, if I say one more thing about land, it goes in two ways, right? Like if you build a factory, it only declines. Land goes in two ways. You not only lose the carbon now, but if you stopped using it, you would regain the carbon. So there's always a cost to using land, always an opportunity cost to using land.
Next question.
Yes, for Tim, yes. Okay, so you provided us a nice picture of the trade-off between environmental and food security issues, addressing the importance to increase productivity. But what about food losses that put into question the way the food system is conceived? And this also, and also about, I am some concern about, the consumption. You addressed the need to reduce consumption, but as John Kenneth Galbraith states a centuries ago, the consumption, the demand is actually an artifact of the supply because it's conditioned by the supply. So that's an issue.
Clear question. Is it marginal or is it quite an amount of loss that we have there?
Food loss and waste. So yes, we have a lot of food loss and waste. And if you try to come up with a solution for the future, one of them is to reduce that food loss and waste. But people think it's easy. It's not. So let's say we lose about 25% of the food on average. It's not that one person is losing that. It's your 5 or 6 different stages of losing that. You lose a little bit at harvest, a little bit at storage, a little bit at transportation, a little bit at processing, a little bit in the grocery store, a little bit in the home. Right? And so each person is only losing 4 or 5%, or each stage. That's not that much. So it's not easy. So people think, oh, it's easy. We just kind of wave our hands and we'll reduce food loss and waste. It's hard. And we have to be realistic about how much we're going to reduce it.
And you said also, Tim, yesterday when we prepared, it is not an or. We do have to do everything, every kind of measure, plus the ones that you propose. Next question for David.
Thanks, David, for the wonderful talk. And I'm not sure if I understood correctly, but there's no influence if you use tillage or no tillage. But I wonder if you also consider the economic point of view. So what is cheaper for the farmers, to use tillage or not tillage?
No, I didn't look at this, but I think it's also quite dependent of the context, because if you look at I think the profitability of the system combining glyphosate-resistant crops plus glyphosate without tillage, they are quite high, especially if you apply them at very large scale. But if you look at system with complex crop rotation, soil cover, no herbicide, then the cost is much higher. So I don't think there is a definite answer to this question. But at least I think it's quite profitable, at least in some places, yes.
Yes, next.
Yeah, and it's a question for Tim. And yeah, thanks both of you for very nice presentations. I think we're in Europe at a place where we need to decide on a whole range of policies that supports our soils going forward. And you seem to say that we shouldn't use this way of sort of certifying carbon removals. But in this whole process of designing a new institutional arrangement for the soil, what's the most important message that we should sort of bring forward to policymakers in this upcoming discussions?
I think two things that this crowd can do. One is it should make this point that if you really reward each farm, each field, you're creating a high risk that you're just going to reward people for moving the carbon around the landscape rather than increasing it. And so you should be activity based. And the second is you have to factor in a cost for using land. And if not, you're going to be rewarding activities that reduce yield and disincentivizing activities that increase food production. And so I think those are the two critical things. And Europe, it's not that different from the fact that Europe basically outsourced a lot of heavy industry to China and claimed all these greenhouse gas reductions, and is outsourcing food production and claiming all these greenhouse gas reductions. And as I said, in a global model, so I think I was asked about the global model. Every global model assumes, even without policy, that Europe will have some reforestation and that will help offset some deforestation elsewhere. Why? Europe and the US, we were so bad in the past. The forests were all gone in the past. We don't have the population growth. We're not going to continue we can't eat any more meat than we were already eating, right? So if you have any yield gains, you're going to reduce land. That's built into the models already. So if you don't do that, right, then you're worse off. So so that's the basic thing. But those would be those two lessons: factor in the cost of land, and don't actually go to payment by field based on the carbon you measure.
Last question, and I predict that during the coffee break, you will, both of you, be jumped at by other scientists. Short question for Tim.
Short question for Tim. Europe is investing heavily at the moment in agroecology for the future as a solution. What's your point of view on that?
I'm in favor of high-tech agroecology. So if you basically mean anything that just reduces yield or shifts from food production to non-food or whatever, I don't think it's good. But I think there are all kinds of things that you can think of as high-tech agroecology, right? Can you come up with methods that increase nitrogen use efficiency with this type of crop or that? I'm personally obsessed with this question of whether we can actually turn crop residues into a more digestible feed, or whether we can find ways to improve grasses to make them more digestible. And so those are things that I think we need to do. But the basic measure is don't do it at the expense of yield.
Tim Searchinger and David Makowski, applause, please. Thank you very much for the presentation.